Welcome to lecture number 80. We are studying transient analysis, and in this lecture, we will analyze this circuit involving an inductor and two resistors along with a voltage source having DC voltage V magnitude. So in this circuit, the switch K, this is switch K, it has been in position 1 for a very long time unless the circuit achieved steady state. This is a similar problem that we solved for another circuit for which we had a capacitor here instead of inductor, and the remaining circuit was the same. Right. So this switch is in position 1 and it remained in position 1 for a very long time unless it achieved steady state there, and then it was moved to switch to position number 2. Right. So let's see what would have happened at time t is equal to 0 minus. Time t is equal to 0 minus is the time just before we have changed the position of the switch from 1 to 2. Right. What would have happened when this inductor would have achieved steady state? In steady state, the inductor would have been short circuited and there would be only two components in the circuit effectively, V and R1, which is also equal to R. V and this R1 are the only components in the circuit. So I through inductor at time t is equal to 0 minus, just before we have changed the position of the switch, is V over R, whereas the voltage drop across it is 0 because it has been replaced with a short circuit after the circuit has achieved steady state in position 1. Right. Now the inductor is fully energized, like the capacitor is fully charged. It is fully energized with current equal to V over R. So as soon as we move the position of the switch from 1 to 2, and we'll disconnect it from here, this inductor will start acting like a current source, causing a current flow through resistor R2 in this direction, in clockwise direction, So the current, since the current through inductor cannot change suddenly, therefore the current would remain V over R even after we have moved the switch from position 1 to position 2. And what happened with the V across inductor? That's pretty interesting because the voltage drop across inductor can change suddenly. Since we have changed the position of the switch from 1 to 2, now we have this inductor and this resistor, they are in parallel. So the voltage drop across the resistor would be the same as the voltage drop across inductor. And that voltage drop across R2 is the current at which this inductor is charged, multiplied by the resistance I multiplied by R. VI, where I is V over R times R. So it is V. V is the voltage drop across this resistor R2 and across this inductor at time t is equal to 0 plus. And at time t is equal to infinity, what would have happened? As we have studied that a charged capacitor works like a voltage source, but for a short period of time. Similarly, a charged inductor or an energized inductor works like a current source, but for a limited time. As the time passes, it loses its ability to cause a current flow through R2. So the current through R2 decreases and finally becomes 0. And since the current is 0, the voltage drop across R2 and voltage drop across L, they are also 0 as the time approaches infinity after we have moved the position of the switch. So this is the transient analysis for time t is equal to 0 minus, 0 plus, and time t is equal to infinity. And now you will be waiting for the expressions for I of t and v of t for all values of time. For that, we have to write this KVL equation, right? Like we have already been doing. Since this is a series circuit, we'll write a KVL equation for this. This equation is the voltage drop across inductor is L times the time derivative of current plus R times the current. R times the current is the voltage drop across resistor. So that is equal to 0. And if we solve this, it will take us to a general solution for which we have this K1, K2 and tau unknown. And by putting the values of I at time t is equal to 0 and at time t is equal to infinity, it gives us K2 is equal to V over R. And if we put V over R, K2 is equal to V over R. In this expression, we get I2 of t is V over R e to the minus t over tau. But we still have one unknown, that is tau. For that, we'll put the current I2 of t that we have computed in 2, we'll put that in equation number 1, like we have been doing previously. So when we do that, this time derivative of I2 of t, time derivative of I2 of t gives us this, plus R over L times this, I2 of t. And then if we solve, we can take this much quantity as common. And if we divide that from on both sides, this becomes 1 times this, the same. And this is 0 divided by the same. It remains 0. So this is 1 over tau equals R over L. Our tau is L over R. So the time constant for this circuit is L over R. So I2 of t comes out to be V over R e to the minus t R over L. And if you plot it, it is plotted like this. It's a decreasing exponential having a value V over R at time t is equal to 0. Right. At time t is equal to 0, this is V over R, and then as time increases, the value decreases and becomes 0 as the time approaches infinity. And then the last thing of this lecture is to compute V sub L of t, the voltage drop across inductor. And that is VL of t, V sub L of t can be computed as L times the time derivative of the current flowing through it. Since the current flowing through this is di2 of t by dt, and the current flowing through it can also be written as I sub L, but I sub L has a direction opposite to I sub L has a direction opposite to I2. Therefore, we have to put a minus here, and then if we compute the time derivative of I2 of t computed here, multiplied with the value of inductance L, it gives minus V e to the minus TR over L. And it is plotted like this. In our last lecture, we learned plotting different functions in MS Excel. So you can put different values of V, R, and L, and then we try different values. You can set V, R, and L constants, and then we can try different values of T to get this function plotted in MS Excel. For that, you are referred to my last lecture. Right, so that's all for this lecture. In our upcoming lectures, we'll keep on studying our main topic, transient analysis of circuits. Thank you.